Hi everyone, welcome to this video lecture on Unit 5 Special Theory of Relativity Part 6. In this video lecture, I would like to explain addition of velocities and Einstein's mass energy equivalence relation. The first topic is addition of velocities. Let us consider two initial frames of reference S and S dash, and let S be at rest and S dash be moving with a velocity v bar relative to S in the positive x-axis. Suppose a body moves a distance dx in a time dt in frame S, then the same body appears to move through a distance dx dash in time dt dash in frame S dash due to relativity. Then dx by dt is equal to u and dx dash by d dash is equal to u dash. That is equation 1, where u and u dash be the velocities of the body in frames S and S dash respectively. From Lorentz transformation equations, we have x is equal to x dash plus v dash by square root of 1 minus v square by c square. That is equation 2. And t is equal to t dash plus vx dash by c square by square root of 1 minus v square by c square. That is equation 3. Differentiating equation 2 and equation 3 with respect to t, we get dx is equal to dx dash plus v into dt dash by square root of 1 minus v square by c square. That is equation 4. And dt is equal to dt dash plus v into dx dash by c square whole by square root of 1 minus v square by c square. That is equation 5. Dividing equation 4 by equation 5, we get dx by dt is equal to dx dash plus vt dash v dt dash by dt dash plus v dx dash by c square. Dividing numerator and denominator by dt dash, we get dx dash by dt dash plus v whole by 1 plus v by c square into dx dash by dt dash. Here dx by dt is equal to u and dx dash by d dash is equal to u dash. Therefore, u is equal to u dash plus v by 1 plus u dash v by c square. That is equation 6. This equation represents the relativistic law of addition of velocities. Special cases. Case 1. When u dash and v are small as compared to c, then u dash v by c square can be neglected in comparison to unity. That means the velocity of the frame S dash or the velocity of the body with respect to frame S dash are comparable to c. That means they are very small when comparable to c, then u dash v by c square can be neglected. Therefore, from equation 6, u is equal to u dash plus v. That is equation 7, which is classical formula. When u dash or v is equal to c, then u is equal to u dash plus c by 1 plus u dash c by c square. That is equal to u dash plus c by c plus u dash. That is equal to c. That means u is equal to c. That means if the second frame of reference S dash or the speed of the body with respect to frame S dash is equal to velocity of light, then their relative velocity also equal to velocity of light. This is according to second postulate of the special theory of relativity. This can be explained as, if one object moves with velocity c with respect to other, then the relative velocity is always c, whatever may be the velocity of the other. Now, The second topic is Einstein's mass energy equivalence relation. According to Einstein, mass can be converted into energy or energy can be converted into mass by using a formula E is equal to mc square, that is called Einstein's mass energy equivalence relation. This can be derived as, according to Newton's second law, the force is the rate of change of momentum, hence F is equal to d by dt of mv, that is equation 1. According to theory of relativity, the mass as well as velocity are variables, then F is equal to m into dv by dt plus v into dm by dt, that is equation 2. When a particle is displaced through a distance dx by the application of a force F, then the increase in kinetic energy is given by dk is equal to F into dx, that is equation 3. From equations 1 and 2, we get dk is equal to m into dv by dt into dx plus v into dm by dt into dx, where dk is equal to mv dv plus v square into dm, that is equation 4. Now, the variation of mass with velocity according to theory of relativity is given by m is equal to m0 by square root of 1 minus v square by c square, where the body is moving with velocity v comparable to velocity of light. Here m0 is rest mass of the particle and c is velocity of light, v is the velocity of the body. Squaring on both sides, we have m square is equal to m0 square c square by c square minus v square, or m square c square minus m square v square is equal to m0 c square. Differentiating this equation, we get c square into 2m dm minus v square into 2m dm minus m square into 2v dv is equal to 0, or c square dm minus v square dm minus mv dv is equal to 0, or c square dm is equal to v square dm plus mv dv, that is equation 5. Comparing equations 4 and 5, we get dk is equal to c square dm, that is equation 6. Now, consider that the particle is at rest initially and by the application of force it acquires a velocity v. The mass of the body increases from m0 to m. The total kinetic energy acquired by the body is given by integral dk is equal to integral m0 to m c square dm. Therefore, k is equal to c square into m within the limits m0 to m, that is equal to c square into m minus m0, that is equation 7. This kinetic energy is called relativistic kinetic energy of the particle. If the velocity of the body is very small when compared with velocity of light, then the relativistic kinetic energy becomes equal to ordinary kinetic energy. The rest energy of the body is given by E0 is equal to m0 c square, that is equation 8. Therefore, the total energy of the body is E is equal to kinetic energy plus rest energy is equal to c square into m minus m0 plus m0 c square is equal to mc square. That means E is equal to mc square, that is equation 8. This is called Einstein's mass energy equivalence relation. According to this equation, a mass m can be converted into an energy equal to mc square. Similarly, from the energy we can create a mass equal to E by c square. This is a very important equation. In this way, we can explain the topics addition of velocities and Einstein's mass energy equivalence relation. I will explain the 4 vector formalism in the next video lecture. Thank you.